This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we're tackling a fascinating and somewhat mind-bending paper. If loud aliens explain human earliness, quiet aliens are also rare. It proposes a rather unique explanation for humanity's seemingly early appearance in the universe's timeline. What's the core argument presented in this paper?
The paper centers on the idea that humanity's emergence might be surprisingly early, statistically speaking. They use a hard steps model of evolution, suggesting that reaching our level of advancement requires overcoming numerous difficult hurdles. The probability of achieving this within a given time frame increases dramatically with time, implying that most advanced civilizations should appear much later than us. However, since we haven't observed any other advanced civilizations, this suggests something is amiss.
So if the statistical probability suggests we should be much later, what's the paper's proposed solution to this apparent paradox?
The paper introduces the concept of loud and quiet aliens. Loud aliens are expansive, long-lasting civilizations that significantly alter their environments, making their presence easily detectable. Quiet aliens, on the other hand, are harder to spot. The paper argues that the existence of loud aliens could explain our early appearance because their expansion would effectively set a deadline for other civilizations to emerge before their territory is claimed.
That's an intriguing idea. How does the paper model the behavior of these loud aliens?
The model incorporates three key parameters: the rate at which loud alien civilizations are born, following a power law related to the number of hard steps in evolution, their expansion speed, and the power of the birth rate's time dependence. They use data from Earth's history to estimate the number of hard steps and the lack of visible alien structures in our sky to constrain the expansion speed.
The paper mentions a hard steps model. Can you elaborate on what that means in this context?
The hard steps model posits that evolution towards advanced life involves a series of difficult, time-consuming stages. Each step has a certain probability of occurring within a given time frame. The more steps involved, the longer it takes, and the probability of reaching a certain stage increases as a power of time. This is similar to models used in cancer research, where multiple mutations are needed for cancer to develop.
So the model suggests that the probability of a civilization reaching our level of advancement increases significantly over vast timescales. How does this relate to the loud alien hypothesis?
The model shows that if the number of hard steps is significant and the maximum lifespan of a habitable planet is not extremely long, then the probability of a civilization appearing as early as humanity is very low. The loud alien hypothesis suggests that these loud civilizations, expanding rapidly, create a deadline, a point in time after which it becomes impossible for other civilizations to emerge without being overtaken. Our early appearance, therefore, might be a consequence of this cosmic land grab.
The paper also discusses quiet aliens. How does their existence factor into this theory?
Quiet aliens are much harder to detect, making it difficult to estimate their prevalence. The paper uses the model to explore the implications of both loud and quiet aliens, showing that if loud aliens originate from quiet ones, the probability of a quiet alien civilization ever existing in our galaxy would be incredibly low. This has significant implications for the search for extraterrestrial intelligence, SETI.
What are some of the key predictions of this model, and how could they be tested?
The model makes several predictions, including the likely number of galaxies controlled by loud alien civilizations, the time until we might encounter them, and the potential visibility of their expansion boundaries in the sky. These predictions could be tested through further astronomical observations, searching for subtle anomalies or patterns in the distribution of galaxies or cosmic structures.
The paper discusses the implications for SETI. What does the model suggest about the likelihood of finding other civilizations?
The model suggests that if loud aliens are common and arise from quiet ones, the probability of finding another quiet alien civilization, even in our galaxy, is depressingly low. This is because the rapid expansion of loud civilizations would leave little room for others to develop without being overtaken. However, the model also considers the possibility that the differences between alien-controlled and uncontrolled volumes are subtle, which could increase the chances of detecting them.
What are some of the limitations or assumptions of this model?
The model relies on several assumptions, including the validity of the hard steps model, the uniformity of the universe on large scales, and the consistent expansion speed of loud alien civilizations. It also simplifies the interactions between civilizations and the appearance of their controlled volumes. Future research could explore more complex models that relax some of these assumptions.
The paper mentions the possibility of subtle differences in alien-controlled volumes. How does this affect the model's predictions?
If the differences are subtle, we might not have noticed them yet. In this case, the model's predictions about expansion speed become less certain, but it still provides insights into the distribution of civilizations and the potential for detecting them through the search for subtle circular borders between volumes.
The paper uses a power law to model the birth rate of civilizations. How robust is this assumption?
The paper acknowledges that a power law is a simplification. They test the robustness of this assumption by comparing it to a more realistic model that incorporates factors like star formation rates and planet lifetimes. They find that a power law provides a reasonable approximation over a significant portion of the parameter space, particularly for larger powers and longer planet lifetimes.
What are the broader implications of this research?
This research highlights the potential for using statistical models to address fundamental questions about the prevalence of life in the universe. It challenges us to consider the possibility of expansive civilizations and their impact on the observable universe. It also underscores the challenges and uncertainties involved in searching for extraterrestrial intelligence.
This has been a fascinating discussion. Thank you for shedding light on this thought-provoking paper. It certainly gives us a lot to consider about our place in the cosmos.